Welcome back. In this next section, we're going to dive into blockchain use cases. We're going to talk about how do you know where to apply the technology? What are some good indicators to look for that you might have found a good blockchain use case? What are some good patterns or common properties of blockchain use cases? And then we'll end out talking about some real world implementations and where this technology is being used currently. So let's go ahead and dive in. So let's start off talking about how do we know when to use blockchain? And I'll begin this just by sharing a little bit of my personal opinion. And keep that in mind that what I'm about to share is nothing more than just one person's opinion. So don't take this as anything definitive. Um, but I am of the opinion that the best technical solutions are the ones that meet all the requirements with the absolute simplest design. And there seems to be a perception in the world of technology that the best or the most elegant technical solutions are the ones that use the most technology or the ones that are the most technically complex. Um, and I'll give you a great idea of how I view this. We can look at a real life example. Early in 2020, it may seem like a long time ago, but the United States was mired in an impeachment trial. And after the beginning of the trial, after the House managers made their argument and the president's defense lawyers presented their defense, there were 2 days of questions and answers in which the senators got to ask either the House managers or the president's lawyers or both a question. And the way this was structured, anytime a senator wanted to ask a question, he or she would write down that question with a pen on a small slip of paper and hand that paper to a Senate page. The Senate page would then physically walk that piece of paper down to the Chief Justice, who would read the question, and if he decided it was appropriate, would then read the question aloud and give one or both sides time to respond. And at the time, this was ridiculed, particularly in the technology world. Here was the United States Senate, presumably the most prestigious legislative body in the whole world. In the United States, which prides itself on being a world leader in technology. In the year 2020. And many people said, this is the best we can do. Pen and paper, we can't come up with some more technical, elegant solution. And if you look at the requirements, you start to see that this actually was an example of the perfect technology solution. You see, there were a couple things that really worked in its favor. First of all, this question and answer period was only going to last 2 days. So getting someone trained up on how to use a new app or a new online system for 2 days of use might not have been the most efficient time. You don't have to train anyone how to use pen and paper. And that training might have been more complex or time consuming than we might first imagine, given that the average age in the US Senate is approaching 70 years old. Generationally, you just have folks who aren't as comfortable with this technology. It's not as native in their life. And finally, and maybe most importantly, the security aspect. United States impeachment trial, impeaching a sitting president, is a fairly high profile event and might be an attractive target for hackers or anyone who just wanted to cause a little chaos. Well, cybersecurity is not nearly such a big concern when you're working with pen and paper. So, it really was the simplest technical solution that could meet all the requirements. And so you'll see me express this as a theme when I talk about how to select and evaluate and scorecard a use case. I always like showing this little flow chart that you see here on this slide when I talk about this, not because I think that the answer to a do I need a blockchain is always going to be no. That's obviously a little bit of a joke. I show this flow chart because when you find a really good blockchain use case, it tends to be so obvious that blockchain is a technology that can solve a problem no other technology has been able to, that very often you don't even bother asking this question. The answer is already pretty obvious. And so we're going to dive into this philosophy a little bit deeper in this section, but I just wanted to start off giving you an idea of how I approach use case selection and evaluation. All right. Well, once you've decided that you want to use blockchain, that you've got a good use case, you'll find that there are a lot of really good materials out there. Surveys, flowcharts, decision matrices, essays, YouTube videos, etc., to help you narrow down what is the right blockchain platform or technology to build on top of. But all that assumes you're already at the point where you validated that you've got a good blockchain use case. And oftentimes just getting to that point can be very difficult or very confusing. There is not a lot of good guidance around that. So I've come up with these 4 questions that anybody can sit down and ask themselves or talk about with their stakeholders, their managers, their customers, clients, vendors, partners, whomever they're having this conversation with. And this is a great conversation to have because, as you'll see, these are very non-technical questions. They focus more on the business side. So as long as you're talking to somebody who understands the business that they're in, they should be able to give you some very, very insightful answers. And we'll see how the answers to each of these yes/no questions guides our decision making and lets us know, hey, do we want to budget more time to investigate blockchain, or are we pretty confident that's not going to be a good fit here? So we'll talk about what each of these questions means. But first, let's go ahead and take a look at the spoiler. What does a good potential blockchain use case look like? Well, if you ask yourself these 4 simple questions and you come away with 3 yeses and a no, well, then you might not have an ideal blockchain use case, but you should definitely plan on spending a little more time doing some deeper investigation. There's a very good chance you stumbled across a good use case for blockchain. So let's talk about each of these 3 questions and what they mean and how you might get to 3 yeses and a no. We'll start off with question 1. And question 1 simply asks, do I have one or more assets that I want to track? And remember, anytime we hear this word asset in a blockchain conversation, it's just another way of saying a thing that we care about. So what we're asking here in question 1 is, hey, do I have one or more things that I care about that I want to keep track of? And those things that I care about, those assets, those can be something physical or those can be something intangible, virtual. So a building, an automobile, a piece of jewelry could all be assets. But so could a Bitcoin, a patent assignment, a piece of digital content, intellectual property. All of these could be assets as well. And so what we're asking ourselves in question 1 is, hey, are there one or more things I care about and I want to keep track of? Now, you might have ask yourself this question and come up with a no, and that's perfectly valid. For example, you might say, hey, what I'm really after is a more efficient way for my employees to instant message each other when they're on my corporate network. Well, that's a perfectly valid use case that has absolutely nothing to do with tracking or managing assets. But if we say, yes, I do have one or more things that I care about and I want to keep track of, well, then we can go on to question 2. And we can say, all right, these things that I care about, these assets, do I care about their history, their evolution, their life cycle? Sometimes all we want to know is the current state of something. We don't care about the history. We don't care about how it got to that point. All that we need to do our job, or all that needs to be documented, is just what is the current state. Sometimes that's not enough. sometimes we want to know the history as well. How did this asset evolve? How has it changed over time? So, if we have a use case where we don't care about the history, where all we really care about is just the current state, well, then a database is likely going to be a better solution. It's going to be simpler, easier, knowledge about it, skill sets are more widespread. Remember, databases can do updates and deletes, so they can manage data very, very quickly. The downside of that is they don't preserve version history without a lot of additional effort. However, if that history is important, if I do want to be able to tell the story about how these assets evolve and change over time, well, then blockchain might add a lot of value. And a big reason for that is because it does not have that ability to update or delete. So as changes are made, as things are updated or deleted, we record that by appending a new record to the ledger. And this gives us a full built-in version history for every single one of our data points, just built right in, intrinsically into the solution fabric. All right, so that gets us to question number 3. And to recap, we've said, hey, I've got one or more assets I want to keep track of. Yes. And yes, I care about the evolution, the life cycle, the history of these assets. It's not just enough for me to know the current state. I want to know how they evolve and change over time. All right, well, now we ask ourselves question number 3, and we say, okay, is the evolution or the life cycle of these assets, is that life cycle governed by any rules, any processes? Is it regulated in any way? And 99% of the time, when you ask yourself this question, the answer is going to be yes. There are very, very, very few things that we bother to keep track of in life whose future state is completely and totally unpredictable and random, where we don't at least have some idea of what the next state or step might be. Let me give you an example of this. Let's say the asset we've decided we want to keep track of are employee expense reports. We have some employees out in the field incurring expenses, and they submit expense reports so they can get reimbursed. And we might say every expense report has a status property that indicates where it's at in the reimbursement process. And we might have a business rule in place that says no expense report could ever possibly have a status of paid before it has first had a status of received. If you think about it, that would make no sense. How in the world could we pay an expense before it's been submitted? Most of the assets that we bother to work with in the world fall into this category. There are at least some high-level rules and guidelines in place that help guide the evolution of this asset. Like I said, there are very, very few things whose evolution is completely random and unpredictable. If you are working with one of those rare assets whose evolution is completely and totally unpredictable, well, then likely all you're looking to do is just capture data about its state when it changes. You don't have any way to forecast or facilitate a change into what the next state is going to be. So likely you're just watching and observing and then keeping track of your observations. And if that's the case, conventional technology will likely work just fine there. But remember, this idea of blockchain is workflow, a decentralized shared workflow engine. Well, if we know how these assets are going to evolve and change and grow over time, we can use those workflow properties. We can use smart contracts on the blockchain to help guide and swim lane and facilitate the evolution of those assets over time. All right, that gets us to question 4. So let's go back and recap. Question 1, we asked ourselves, do we have one or more things that we care about that we want to keep track of? And we said, yes, we do. And then question 2, we said, all right, do we care about the history of these things that we care about? Do we care about how they evolved to get to this point? And we said, yes, absolutely. We need to see that history. And so question number 3, we said, okay, as these assets evolve, are there some processes in place? Can we forecast or predict what the next state is going to be? Can we make use of smart contracts to help automate or facilitate those processes? And we said, yes. And so that gets us to question number 4. And this is arguably the most important one. And question number 4 asks, am I the single, sole, authoritative voice of truth for any and all questions about this asset or these assets? And this question is kind of the opposite of number 3. You remember in question 3, I said most of the time, 99.9% of the time, when you ask yourself question 3, the answer is going to be yes. Well, when you get to question number 4, 99.9% of the time, the answer is going to be no. I am not the single, sole, authoritative voice of truth for any and all questions about this asset. You see, most of the time, we are nothing more than one custodian of an asset over one certain phase in its overall life cycle. So let's talk about a quick example. Let's talk about the new iPhone. Apple comes out and they announce the newest generation of the iPhone. So let's say you have questions about the upcoming iPhone model. Who do you ask? Well, at first, you might think that's a pretty obvious question. If I have any questions about the iPhone, I just ask Apple, right? Well, if the question you have about the iPhone relates to the feature set, how much memory is it going to have? How big is the screen going to be? What colors is it going to come in? Well, then you would be right. Apple would be the appropriate entity to ask because Apple designs their products and they could tell you all that. But if your questions were not about the feature set, but were rather about the manufacturing, when will the first batch of these new iPhones be manufactured and ready to go out to market? What date will production start on those iPhones? How many individual components go into the new iPhone model? Well, those are questions that Apple likely wouldn't be able to answer or wouldn't be able to answer directly because while Apple designs their products, they do not manufacture their products. They outsource that manufacturing work to groups like Foxconn. So if you have a question about the manufacturing schedule or the parts list or anything manufacturing related, you wouldn't ask Apple, you would ask a manufacturer like Foxconn. If your question was not about the feature set and not about manufacturing, but perhaps about logistics, maybe you want to know, okay, when is the first container ship loaded up with containers full of these new phones going to arrive in my country? Well, that might be a question for the international logistics provider, a group like Maersk, who's shipping those crates full of iPhones all around the world. If you have questions about when can I buy that iPhone, when is it going to be in my local store? Well, that might be a local logistics provider, DHL, FedEx, UPS, or others. And if you have questions about what is the price going to be, are there any discounts I can apply? Can I keep my same data plan? Well, Apple couldn't answer those questions. Those would be a question for your mobile data service provider. Most of the assets we work with follow this iPhone model. We can only authoritatively and definitively answer questions about this product or this item or this asset in one phase of its overall larger life cycle. I'll give you an example of where the answer here might be yes, one of the rare cases, rare exceptions. In the United States, every U.S. citizen is uniquely identified by his or her social security number. Social Security numbers are issued and managed entirely by the United States Social Security Administration, a federal level office. That means if you ever have a question about a social security number, there is only ever one authority that you go to, and that would be the United States Social Security Administration. This is the exception, not the norm. Again, most of the assets we care about fall into that iPhone category. So let's look at the answers here. If you are somebody like the United States Social Security Administration, if you are already a trusted, centralized authority who is in a position to authoritatively answer any and all questions, well, then using a decentralized approach doesn't make a lot of sense. Why would you use a decentralized technology when you're already a trusted, centralized authority? But in most of the cases, our answer here is going to be no. And that's where using centralized technology can get really problematic. Think about our iPhone example and how siloed all that information is. That's why all these participants aren't able to answer questions outside of their asset custody range. So, if you ask yourselves these 4 questions and you come away with 3 yeses and a no, again, this is no guarantee that you found a good blockchain use case, but you're certainly seeing a lot of the symptoms of a good blockchain use case. We're getting close to making a pretty affirmative diagnostic. All right, let's talk about some indicators to look for. Probably the biggest indicator you can look for that'll tell you that you found a good blockchain use case is one where you ask yourself, hey, why are we talking about blockchain? Why can't we use conventional technology or a centralized approach? If you're analyzing a use case and that question comes up and the answer to that question has absolutely nothing to do with technology and everything to do with human beings, then you have likely stumbled across a great blockchain use case. Let me go a little bit deeper into this. So there's a white paper that I'll link here in the slide deck that Hyperledger wrote about a project they did with the National Association of Realtors. The National Association of Realtors, or NAR, is a trade group here in the United States that is comprised of over 1,200 fully independent, autonomous member organizations and agencies. Now, for years, NAR had an idea for a solution they wanted to build. It was something that they called a member engagement database. And the idea was they wanted to collect information about what individual realtors were doing in their local markets and put it all into a database. And they had a lot of interesting ideas about how to use this data. I'll give you a short example of one of these ideas. So one of these ideas was they might be able to help realtors get up to speed quicker when they relocate or change geographies. So I'll give you an example. I live just outside of Denver, Colorado. And that means every winter we get a few big snowstorms, and at least once or twice a year, there's a snowstorm so big it shuts the city down for a day or two, and we spend all day outside shoveling off the walks and driveways and digging ourselves back out. So let's pretend that instead of teaching blockchain here in Denver, Colorado, I'm a realtor. And in addition to working in the real estate market, let's pretend that I also sit on the Denver Chamber of Commerce and I volunteer with a couple community outreach organizations. And one winter, we have a particularly bad, snowy, cold winter, and I decide, you know what, I've had enough of this. It's time to pack up and move and go somewhere warmer. And so I decide to relocate to sunny San Diego, California, and never have to worry about the snow again. Well, what NAR wanted to do is have all this information about me in their member engagement database. So when I got down to San Diego, they could help connect me with similar types of customers that I was working with in Denver. And when I got down to San Diego, they could put me in touch with the San Diego Chamber of Commerce. And they could put me in touch with similar outreach organizations. And they had a lot of ideas like this on how they wanted to use this data. Now, the important takeaway to the story is that everybody was on board. Everybody loved this idea. If you were an individual realtor, you thought this was a great idea because it was a great way to help further and advance your career. If you were one of the agencies or organizations that those realtors worked for or represented, you thought this was a great idea because it helped you demonstrate the value you were putting back into the communities that you serve. And if you were NAR, if you were the trade group, obviously you thought this was a great idea because all of your individual members and member organizations thought it was a great idea. So everybody was 100% aligned on the idea and the value. There was only one small problem that prevented this idea from going forward for years. And that was this: trying to get 1,200 CEOs, each of whom represents a fully independent and autonomous organization, trying to get 1,200 of them to collectively agree to give up ownership and control of their data, to be placed in a third-party system they don't have any ownership rights over. That was a non-starter. So even though everybody was aligned on the outcome, there was no way to build alignment on the way to get to that outcome. And this is the pattern I want you to look out for if you're looking for blockchain use cases. Imagine that we're all in a conference room having this talk about blockchain and National Association of Realtors and why it might be able to help. And imagine in the back of the room there's someone like me, someone who comes from the IT side of things. And this person like me, they raise their hand and they say, "Hey everyone, I just have a question. I just want to ask something. Why are we talking about all this blockchain stuff? Everything you guys are talking about doing, we could do in a database. Why don't we just use a database instead? Why do we need to use blockchain?" Well, the answer to that question, why won't a database work, had nothing to do with technology. The reason National Association of Realtors didn't use a database for this solution wasn't because a database couldn't handle the data, or it couldn't store it, or it was too many records, or databases were just never built to work with real estate data. The reason that a database wouldn't work in this scenario was completely non-technical. Asking all of these CEOs to collectively give up ownership of this very critical data was just a non-starter. So the barrier to using centralized or conventional technology was not a technical one. It was a human one or a political one. And this is what you want to be on the lookout for. If you're addressing a use case, and the reason why you think conventional technology will not be appropriate has everything to do with people and nothing to do with the ones and zeros, then you've likely found a good blockchain use case. Now let's go a little bit deeper into this. Look at a real world example. So, one way that I like to talk about blockchain and Web 3.0 technologies is as IT spending 2.0. And what I mean by that is, if you look at the first 30, 40 years of IT spending, organizations were spending money on technology because they wanted to get a certain set of benefits. Organizations traditionally have spent money on technology because they want to increase communication, efficiency, transparency, collaboration, effectiveness, etc. And over the past 30 or 40 years, we've realized some incredible gains, but we're starting to get to the point where additional dollars spent on internal IT are yielding fewer and fewer of these benefits. Now comes blockchain and Web 3.0 and this wave of decentralized technologies. And the way you can think of this going forward is that for the next few decades, we're going to continue to spend money on technology because we want to continue to get exactly those same benefits of collaboration, communication, transparency, efficiency, effectiveness, and more. But now we're spending money on technology to get those benefits between organizations, not within the organization. Because this is where a lot of the friction in the business world is coming from right now. Your organization might be lean and efficient and have great transparency and communicate very well and collaborate efficiently. In my organization, might collaborate very well and communicate excellently, have great transparency, amazing efficiency and effectiveness. But then when we go to work together, we find out our approaches are different. I can communicate great internally and you can communicate great internally, but we have a lot of problems communicating between organizations. I can collaborate great internally and you can collaborate great internally, but it all kind of falls apart when we try and leave the sandbox and play together. And so blockchain and these Web 3.0 technologies are really stepping in to help us realize all these same set of benefits, but now we're doing it between organizations, not just within the castle walls. And this is becoming increasingly important because the business landscape is changing very, very fast. Great example of this taking place right now is the automotive industry. The big event every year, if you follow the automotive industry, is the Geneva Auto Show. It happens in March of every year, except for 2020, for obvious reasons. But in March 2019, there was a theme that emerged very organically at the Geneva Auto Show. This was not planned. This was not part of the official content. But if you were there in Geneva in March of 2019, you heard everybody talking about this idea of collaboration and competition. That people, organizations, entities in this industry are going to have to start working together if they want to survive in order to be able to compete with each other. You can see some of the quotes there talking about what's going on. Essentially, the automotive industry is facing two existential challenges right now, two enormous challenges. And if you are an automaker and you want to survive into the coming decades, you need to have a solution in place, not just for one of these challenges, but for both. And each one of these challenges are so large and so complex that no one automaker can really afford to take them on by themselves in a vacuum. And those two big challenges are, number one, the electrification of our vehicle platforms. Moving away from internal combustion and fossil fuels towards electric platforms or more renewable platforms. So challenge number one. Challenge number two, smart cars, autonomous vehicles, self-driving vehicles. How do we continue to safely and securely reduce the workload on the driver over time until we can convert the driver into a passenger? Both of these are enormous challenges. And like I said, if you want to survive into the coming decades, you need a solution to both, not just one. And so this has led a lot of participants in the automotive industry to start teaming up in new and unexpected ways. For example, just before Geneva last year, Daimler, the parent company of Mercedes-Benz, announced that they were teaming up with BMW to co-develop autonomous vehicle technology to go compete with Uber and Lyft. Now, these two brands, Mercedes-Benz and BMW, are two brands who traditionally had been viewed as competitors, direct competitors with one another. Yet here they are collectively spending over 1 billion US dollars to co-develop technology. And it doesn't stop there. Just after Geneva last year, Ford and Volkswagen made a similar announcement. Ford and Volkswagen announced that they were going to team up to create electronic vehicle technology, electronic powertrains. And if you think about what's going on, it's pretty incredible. These are pretty new relationships. Let's look at Ford and Volkswagen. So they are going to team up and they are going to cooperate, work together to develop new technology. Then they are going to take this technology, each one of them, and they are going to put it into their respective vehicles, which they will then compete with each other to sell to you. So they are literally working together or collaborating at the front end in order to enable competition at the back end. Very, very new and unconventional business relationships. But this is the new world that we live in now. And so you can think about all the areas of a traditional IT initiative or IT project that can be challenging. The things you see listed on this slide, things like DevOps, information security, change management, product and program management, even marketing and branding. How do you sell the value of the product or service that you're creating? All of this can be challenging for a project inside one organization. Think about how much more challenging all this becomes if we have multiple organizations collaborating together on a solution. For example, what happens if you have a great, rock solid, well-documented, ultra-efficient change management process, and I also have a well-documented, super efficient, great change management process. But we go to work together and we find out our change management processes are different. How do we reconcile that? So there's a lot of room in this blockchain decentralized world, not just for technical folks, not just for the architects and developers and coders and system administrators, but really for everyone, because we all have to figure out how we're going to be successful with these new types of business relationships and business models. But back to our discussion, imagine if you're the CTO, the chief technical officer of one of these two companies, either Ford or Volkswagen. And your mission is to go build out the technological infrastructure that will support this new business relationship. Ask yourself, as the CTO of one of these two organizations, if we take a conventional approach, whose database are we going to put all this stuff in? Is Ford going to own and control the database and just be nice enough to give Volkswagen access? Is VW going to own the database and let Ford have access? Are we going to look at some kind of weird scheme where maybe we split the data schema and each one gets to own half, so it doesn't really serve as information of value unless you can put both halves together? There's really no solution you can think of using centralized technology where everyone's going to go home happy. And that's because databases and centralized technology, they have an owner, they have an administrator. If I set up a database, that database is mine. And if I want to let you into it, that's my decision. That's a much different environment than one in which we both collectively own the asset. I own half and you own half. So again, just a pattern you really want to be on the lookout for. If you're analyzing a use case and you ask yourself, okay, whose database or centralized system are we going to put this in? And you can't come up with a good answer. And the reason you can't come up with a good answer is because of people, not because of technical limitations. Well, then you're on the right path to finding a good blockchain use case. Think about Ford and Volkswagen. Is the reason why a database would be inappropriate here a technical one? Is it because databases cannot store information about automotive engineering and design? No, it has everything to do with the humans and their politics and their feelings. um, So yeah, just kind of a recap here on this slide. Remember, centralized technologies have an owner, like the name implies. They are exclusively and totally controlled by one entity. And that's great. A lot of times that's what we want. But in those use cases where that's not what we want, where that's not appropriate, we need a different kind of architecture. And that's what Web3 is really all about. Starting to explore architectures that will enable these new types of business relationships and solutions. All right, let's talk about an interesting potential use case, something in the real world. Very interesting startup right now, based out of Canada, called Carbon Engineering. If you're interested, check out carbonengineering.com and you can learn more about their technology and what they're up to. But this is a startup based in Canada that is working on developing a technology called direct air capture. They're not the only ones. There are several different groups and startups and researchers working in direct air capture. But what Carbon Engineering has prototyped and designed is what you see in this picture, these large cooling tower type structures. And what they have are these large fans that circle atmospheric air through the structure. And inside the structure, they have a special chemical solution that rains down and comes into contact with the air. And when it does, the special solution that they've developed goes through a chemical reaction where it's able to bond to the carbon dioxide in the air and literally pull carbon out of the air. And there are two very, very interesting things that could potentially be done with this carbon. Number one, right now, this technology in its prototype state, it's still not ready for market, it's being prototyped, but right now in its unfinished state, we could make synthetic fuel from it. In other words, we could take this carbon that we pull out of the atmosphere, chemically bond it to hydrogen and create synthetic hydrocarbons, synthetic fuel that would run in conventional engines, in your car and jet engines and everything in the world around us today. And Carbon Engineering estimates that they can sell you a gallon of this carbon neutral gasoline for only 10 cents a gallon more than what you're currently paying at the pump. That's kind of the short-term opportunity. The longer-term opportunity this technology opens up is carbon sequestration, pulling carbon out of the air and putting it back underground to take it out of the atmospheric cycle. So there's a lot of potential for this technology, but there are two big challenges. The short-term one, if we're going to start making and distributing carbon neutral fuels, well, we're going to need a way to account for the distribution. You see, if Carbon Engineering is going to sell us this fuel at a 10 cent per gallon premium, we have to assume that is only going to be possible because they're using existing distribution methods. In other words, Carbon Engineering is likely not planning to go out and build their own refineries and their own pipelines and their own tankers and their own trucks and their own fuel stations. When this fuel becomes available, if you go to the gas station and you fuel up your car and you're purchasing this fuel, what is actually going into your tank is likely a blend of traditional fuel and carbon neutral fuel. So when you make your credit card payment at the pump, how is that payment distributed? How is it allocated? Is this something we could keep in a database? Well, sure. There's no technical reason why a database wouldn't be able to store and manage information about fuel purchases. But who's going to own that database? Is that going to be Carbon Engineering? If it is, how are those competitors to carbon engineering in traditional fossil fuel development going to feel about a potential disruptor being the owner and administrator of this data? Are we going to let one of the conventional fossil fuel companies, Exxon or BP or Shell, are we going to let them own the database? If so, how is carbon engineering going to feel about that? Do we say, okay, it doesn't make sense for any participant to own this database? Let's have the US federal government own and manage this database. Well, that might sound like a good solution until you consider the fact that climate change is a truly global problem. How are other governments and NGOs going to feel if one particular government owns and controls that database? So we have here a great example of asking ourselves, hey, whose database should we put this in, and not coming up with a good answer. And the reason we can't come up with a good answer has nothing to do with any kind of technical limitation. It has everything to do with humans and their political feelings on these matters. The second longer term challenge, obviously there's no capitalistic incentive, there's no economic model to be able to pull carbon out of the air and put it underground and make that profitable. There's no incentive for the market to do that right now. And that's where we need larger actors like governments to come in and to create that artificial market through things like cap and trade, carbon credits, tax credits, things like that. And that's likely going to involve a lot of micropayments and microtransactions, something that the consumer side of blockchain, platforms like Ethereum excel at, with the ability to create your own custom coins or tokens for specific use cases. So one very front and center use case where we might see blockchain really step in and add a lot of value. Let's just talk about some general patterns to be on the lookout for, things that make a good sign, make a good use case, or things that sometimes people overlook or misunderstand. And this first one is a big misunderstanding. This is preventing a lot of organizations from taking a serious look at this technology right now and going further with it. And that is, there is the unfortunate perception right now that blockchain and decentralized technologies exist to replace your legacy systems. And nothing could be further from the truth. All else being equal, blockchain is not a technology to come replace your legacy system. It's a technology to enhance that legacy system. We'll talk in a few slides about systems integration, one of the great low-hanging fruits for a first blockchain project. But if you or your organization or organizations that you work with are hesitant to jump into the blockchain waters solely because of this, because the perception is that, hey, that's going to involve ripping out all our legacy systems and replacing that, and we just can't go through the business disruption or personal headaches of managing all that, well, then go out and educate those stakeholders and let them know this is absolutely not the truth, that properly used, blockchain is not a technology that will replace your legacy systems. It's actually one that will enhance the lifetime of those legacy systems and will result in fewer system replacements or migrations. Again, we'll get a little bit deeper into a potential architecture here in a couple slides. There's a lot of confusion just generally about databases and blockchain. And that is because if you look at them on the surface, they look very similar. They look almost identical. They seem to be doing almost all the same things as each other. And so there's a lot of confusion about, hey, are blockchain a replacement for databases? Should we just keep using databases because blockchains aren't a suitable replacement? Can we use both together? And all this can be very confusing. And what really helps to clarify is when you take a step back and look not at the superficial feature set, But what was each of these tools designed to do? What is their primary purpose? What is it they're trying to achieve? Because when you look at what their desired outcome is, what they were designed and architected for, you see that they're after two very different things. So let's start off with databases. What is the primary purpose of a database? Well, databases have been designed from the beginning around rapid storage and retrieval. Databases are all about rapidly storing and retrieving large volumes of data or large binary objects, blobs. Blockchain, on the other hand, has been designed as a logging engine, a historian, a transaction processing engine. So databases are all about performance. They're all about this rapid storage and retrieval. And if you've ever built an application on top of a database, you probably are familiar with this behavior that I'm going to describe, where you have a transaction and you submit that transaction to your database. And you wait a little while for an acknowledgement to come back, and you don't get one. So you send your transaction again, and you wait for an acknowledgement to come back, and you don't get one. So you keep resending your transaction and waiting until finally you send that transaction and you get an acknowledgement back. The database says, hey, I got your transaction. I'm going to go ahead and process it. Well, if you're building an application on top of a database, what I just described is completely normal behavior. This is just a database doing exactly what databases were designed for. And all of those times when you submit your transaction and you're waiting for that acknowledgement and you're not getting it, what's happening is your database is getting that transaction and it's ignoring it. It is intentionally dropping it. And it is doing that because that database is trying to maintain a certain minimum level of performance. And if the workload increases so much that it can't maintain that minimum level of performance, it's just going to start to ignore parts of the workload. And this is not problematic. This is not an error. This is not a bug. Again, this is a database doing exactly what they've been designed to do for decades. Blockchain, on the other hand, is the opposite. Blockchain offers something we talk about as 100% transaction resolution. And what that means is if you submit a transaction to a blockchain network and that transaction makes it there, in other words, there are no network errors or disconnects or anything along the way. If that data makes it to the network, you will always get an acknowledgement back. You will never, ever, ever have to try to send that transaction a second or a third or a fourth time. The trade-off for that is performance. If blockchain is going to accept every incoming transaction, it's not going to be able to maintain that minimum performance level. So for all the superficial overlap, we can see that they're actually very different tools designed for very different purposes. Databases are all about performance. Blockchains are all about accuracy and telling a story. So all else being equal, if you have large volumes of data to work with, keep that data in a database. It's likely going to have a better home there. If you need to tell the story of how that data evolves and changes over time, especially if that story involves more participants than just you or your organization, that's where we can layer blockchain in. And this is not an either or decision. We are never, as solution architects, making a decision between do we want to use database or a blockchain. If appropriate, we can use both. And in fact, some of the most compelling solutions are the ones which combine the best features of a database with the best features of a blockchain into one seamless end user experience. So getting a little deeper, I said we'd talk about systems integration. One of the best low-hanging fruit opportunities for a blockchain project, especially on the enterprise side. Let's say that you and I have a business relationship. You're a manufacturer. You manufacture electronic devices, but you don't sell them. You only focus on design and manufacturing. You rely on a network of resellers like me to go out and sell your products. So let's say one day I have a meeting with a very big potential customer. And the meeting goes very well. And at the end of the meeting, that potential customer says, we want to go ahead and place our first order. Sign us up. We want to start selling these electronic items. And so I've just closed this big order. Awesome. So the first thing I'm going to do when I walk out of that meeting is I'm going to pull out my phone or my mobile device and I'm going to log into my CRM system. Maybe I'm using something like Microsoft CRM on-prem or in the cloud, or maybe I'm using something like Salesforce or Act. But I've got some kind of customer relationship management system where I keep track of all my potential customers and booked business and new opportunities and things like that. And so what I'm going to do is I'm going to go into my CRM system because I want to find this opportunity and update it, because now it's not a sales opportunity anymore. Now it's an actual piece of business. I've got a signed contract. They just signed a purchase order. So I'm going to go into CRM and I'm going to go update that opportunity. Well, when I make that update in my CRM system, how does that get propagated over to your ERP system so that the workers on your factory floor can start manufacturing the items to fulfill that order? Traditionally, this has relied on a lot of rigid integrations and one-off couplings. And if anything changes with either system on either side, we tend to break that very fragile integration. So typically, we just connect these systems directly to each other. Well, imagine putting blockchain in the middle. And when I go into my CRM system and I update that opportunity, that kicks off a transaction on the blockchain. That transaction is subscribed to by your ERP system. So that information makes it from my CRM over to your ERP. Now we've got a working integration. But what we're left with in the middle is really interesting. We have a permanent, immutable record of every single transaction between us. So if an auditor happens to come along 8 years from today and asks, what was the story about this manufacturing job that came in? Why did we manufacture 1,000 crates of widgets? Well, we could always go back and tell the story about how all this started with me meeting with one of my opportunities and closing a deal and getting a signed purchase order. And this permanent, unalterable record of this integration between our two organizations doesn't live in my database or your database or somebody else's database. There's a copy of this data on my nodes, and there's a copy of this data on your nodes. We each have a copy. And this is important. Think about a contract. If you and I sign a contract, maybe I'm going to lease you my car. So I write up a lease agreement and you sign it. Well, what's the first thing we do after that piece of paper has 2 signatures on it? Well, the first thing we're going to go do is find a copier. And we're going to make a copy of that document. And I'm going to keep a copy and you're going to keep a copy. And maybe we give a 3rd copy to a regulator. And maybe we put a 4th copy into long-term safe storage. And maybe we give out extra copies to witnesses. Why do we make these copies? Well, because if there was only one copy of the data, as soon as you were gone, I could just go into the monthly payment line and add a few zeros. And I've already got your signature. So critical data, important data, we tend to want to copy and keep multiple versions of. So If you're looking for a really, really good first use case, some low hanging fruit, a very technically simple implementation, but one that can provide a lot of value, you might want to start looking at systems integration opportunities around you, particularly integrations between systems that span organizational boundaries. All right, I want to finish out just talking about some interesting use cases and implementations where we're starting to see this technology used and some of the value that players in the market are getting out of it. But first, I'll just start with a very interesting report that was released by the World Trade Organization. This came out late 2019, and this was an estimate that they did, which said that over the next 10 years or so, by the year 2030, blockchain has the potential to create an additional $3 trillion in international trade and commerce. To put that into perspective, $3 trillion is roughly the annual GDP of the entire nation of Germany. So we are talking about over the next decade, one technology creating an additional amount of commerce equal to the entire German economy. The reason I think this is such an incredible report or estimate is because even if it's not right, even if it's incorrect, even if they got this estimate wrong, it's still pretty staggering. Think about if they only got this half right, and blockchain only ends up creating an additional $1.5 trillion of international trade and commerce over the next decade. That's still incredibly significant and a tremendous amount of growth. So we are very, very, very early in the blockchain game, and there is a huge amount of potential in front of us. One of the most overlooked news stories in blockchain in the few recent years, I think, has been what Walmart has been doing with blockchain. In late September 2018, Walmart came out with a press release and they announced to all of their leafy green produce suppliers, hey, if you want to keep doing business with us, if you want us to keep selling your produce in our stores, you have until September 2019 to be on blockchain. So if you've been in a Walmart store anytime since October 1st, 2019, and you've seen leafy green produce there on the shelves, you are seeing blockchain at work. And why do I think this is such a significant news story? Well, number one, it's significant because it's an example of a blockchain implementation that we can all look at as consumers. Many of us have been inside a Walmart, and we've certainly seen produce out on the produce aisle. But more importantly, we've seen this sort of thing happen before. RFID, radio frequency identifier tags, technology you've probably heard of. This was a technology that was in place and ready to go, ready for production use for over a decade before retailers really started to adopt it. It really took a while for retailers to see the value. And what really transformed RFID from an obscure technology to something that has become an industry standard was in 2007, Walmart told all of its suppliers, hey, if you want to be able to sell your products in our stores, they have to be RFID tagged. The net result of that, some 13 years later, is that you can walk into a lot of very small stores, mom and pop shops, entrepreneurial ventures, stores that do not make use of RFID technology, but yet most of the items on their shelves that they're selling are RFID tagged. Why is that? Well, likely because that manufacturer is also doing business with someone like Walmart who requires it. Now, some 13 years later, Walmart is making exactly the same move, but this time with blockchain. Will history end up repeating itself? We don't know, but it certainly is something to keep an eye on. Another really interesting story is Mercedes-Benz and what they've been able to do or pilot with blockchain. And this is a great story because you see this play out over and over and over again in the blockchain world, where an organization or a business network will look at this technology because they want to get some benefits. They have some certain use cases in mind. And when they actually go and build out the solution, they find that there were all these other benefits that came along that they never expected or calculated or thought about. So all this started with Mercedes-Benz investing, you can see here, over $110 million on blockchain pilot projects. And this, again, I think just speaks to the future of the technology. 110 million US dollars is far more money than most organizations budget for all their IT expenditures. Mercedes is going to spend this amount of money, and at the end of this, they're not even going to have anything in production they can point to. They've committed to spending 110 million US dollars just on pilot projects, just to explore the potential. So that should tell you a lot about how organizations of the size and caliber of Daimler are viewing this technology and its potential. But all of this started because Mercedes had the idea, hey, wouldn't it be great if we could use blockchain to keep track of all the vehicles that we produce? And not just while they're on the factory floor being assembled, but throughout their whole lifetime. And if we had a way to keep track of all of these vehicles, well, we could also keep track of every single individual part that goes into every vehicle that we manufacture. And originally they were just thinking about doing this largely to help manage recalls and part upgrades and things like that. But what they quickly realized is if they built out a network like this, and they were able to keep track of every single vehicle that they produce, from the moment that assembly started to the moment that car went to the scrapyard and was taken off the road, well, then we're going to have better data about a used Mercedes-Benz than somebody like Carfax. So Mercedes realized, oh, we might be able to go compete in new markets where we haven't been able to compete before. They also realize that they may be able to offer additional services or benefits in areas where they already are competitive. So let's say that you've decided to treat yourself. You've been working hard and saving your money for a long time. You've decided you're going to go out and buy yourself that brand new luxury car that you've been dreaming of. And so you do some shopping and you've got it narrowed down to the new Mercedes-Benz or the new BMW. And you just can't make up your mind. They're both beautiful cars and you like them both. And so you decide one day to go to your local bank or credit union just to talk to them about what financing would look like. Will they give me a loan, and what would the payments and interest rate look like? So you go into your local bank and you talk to the banker and you tell him or her about the vehicles that you're looking at, and they go run some calculations. And imagine that your banker comes back to you and says, all right, here's what I can do. I can finance you on the new BMW at 8% for 60 months. I can also give you the exact same 8% 60-month financing on the Mercedes. Or if you get the Mercedes and you promise to get all the service done according to Mercedes' schedule at an authorized dealership or service center, then I'll knock that rate down to 4%. But if you miss even one oil change or don't get it done on time, that rate's going to go back up to 8%. In other words, that lender may be able to offer you a more competitive rate because of the information that Mercedes is collecting as a manufacturer. If Mercedes can demonstrate convincingly that the car is being well taken care of, then whoever is lending money against the value of that asset is taking a lower risk than if they don't have that information. So, a really great story, and again, you see this happen all of the time, where an organization pursues blockchain and decentralized technology to solve one problem. And by the time they look up, they realize they've opened up new doors of opportunity by addressing that problem or integrating that technology. We talked in our last section about the traveling salesperson problem and the value proposition of enterprise blockchain. And we talked about how there are many business networks out there that are artificially limiting their size and scale, because if they were to scale up any bigger, they just couldn't manage the associated complexity. And a great example of this is FedEx. FedEx is heavily invested in blockchain. You can see here they're calling it a game changer for managing their supply chain. And the reason FedEx is so interested in blockchain has everything to do with these two trucks that you see at the image on the bottom of my slide. On the right, you see the truck with the purple and green FedEx ground logo. And on the left, you see the truck with the classic FedEx purple and orange logo. So what is the difference between these two trucks other than the logo? Well, anytime you see that vehicle on the left with the classic purple and orange FedEx logo, you are looking at a FedEx employee. You are looking at someone who gets their paycheck every 2 weeks directly from Federal Express. When you see that truck on the right with a purple and green logo, you're looking at a contractor, not a FedEx employee. And FedEx makes extensive use of their contractor network, and they primarily use contractors for last mile delivery. In other words, FedEx themselves will figure out how to get your package from the origin distribution center to the destination distribution center. But it's the contractor who takes your package from that local distribution center to your home or to your office. And this creates a real business challenge for FedEx because you, as a consumer, expect seamless tracking information. You should not have to know or care about this handoff to a contractor. And this is exacerbated by the fact that most consumers, the shipping or tracking information they care the most about is that information at the end. When is this package going to show up at my home or office? That's the piece that the contractor controls. Now, if you think about these contractors, some of them are large entities, but many of them are very small ventures, entrepreneurial or even solopreneur ventures. And many of these smaller contractors simply do not have the IT sophistication, knowledge, or budget to be able to integrate their systems seamlessly into FedEx's tracking system. So guess who bears the brunt and the cost of managing all of those integrations? This has gotten FedEx to a point where they really can't scale up the size of this contract network any bigger because of the associated complexity of keeping everybody integrated into their package tracking system. If FedEx were able to help everyone simply integrate to a common platform, that would largely make this problem go away, and they could scale up their network and be more competitive in the market against groups like UPS, DHL, and others. And then finally, I'll talk a little bit about the ROI of blockchain. Oftentimes, when you or an executive stakeholder that you're working with sit down to calculate the ROI of blockchain, it's very easy to focus only on the things that we know blockchain will do. So what is the value of the things this solution is going to do? And let's weigh the value of what we know it's going to do against the cost of implementing the system. And far too often, what gets left out of those calculations is what might this technology prevent from happening. And that's a lot harder to forecast and to estimate with any degree of accuracy, but it's still very important to consider. Because sometimes the areas where blockchain has the biggest impact are in areas where it has or might have prevented something from happening. Couple examples here. We'll talk first about Kerrygold butter, Ireland's most famous brand. Kerrygold butter is sold in supermarkets in many different places around the world. And if you've ever purchased or seen this butter in the stores in your neck of the woods, well, then you've certainly read this claim that they make that the milk they use to make their butter comes exclusively from grass-fed cows, not from cows that are fed grain or on a feedlot or something like that. And all this is great, except that Kerrygold right now is facing a class action lawsuit in the state of California for false advertising. And they're on the hook for a little over 152 million US dollars. And the reason they're being sued for false advertising is because Kerrygold can prove that most of the milk that they source comes from grass-fed cows, but they can't prove that claim 100%. And that small gap in visibility or reporting is about to cost them 152 million US dollars. Now, this has led Kerrygold to look heavily into blockchain. One of the things they've been pursuing is a blockchain IoT solution. Where smart devices can be placed on the cows. Kerrygold will work with the ranchers that they source the milk from to put a smart device on the cow. The idea being if you monitor what comes out the back, you have a very good idea of what went in the front. Another great example of where blockchain might have paid for itself if we'd consider what it might have prevented from happening is what's going on with Boeing right now. As we know, Boeing's troubles started some time ago with the 737 MAX, and they've just gotten worse from there. Production problems in the 787 have been discovered. Engineering defects have been discovered in previous 737 models, not just the MAX, but the 7s and the 8s as well. And then just a series of management missteps and mishaps have all really created a very, very bad storm that Boeing has been trying to weather. Now, certainly this is not to say that using blockchain would solve any of the engineering or mechanical or design issues on aircraft like the 737 or 787. But if Boeing had a way to be able to tell a detailed and convincing story behind every single decision it made, every design decision, and who signed off on it and why, and all the conditions that led to that decision, and all the pieces of input that would be considered. Again, this would do nothing to address any of the mechanical or design issues on the affected aircraft, but it is hard to imagine that if Boeing had that capability, their stock price would be in the same place that it is right now. Might not make all their problems go away, but it would certainly make the problems that they're dealing with right now significantly less painful. So as you're analyzing and scorecarding various blockchain use cases, keep this in mind. It is great to look at the benefits and what blockchain can be expected to do for us and to use those things in our ROI calculations. But it is equally important and oftentimes overlooked to spend some time thinking about what might this prevent from happening. Going back, that's one of the things Walmart was looking at. Food recalls are expensive. And they're expensive not just because you have to recall all that food and refund the customers their money, and you can't put that product back on the shelf and try and sell it again. So you're out that money. And you have to get the message out there. So all of these things cost money. But far and away, the most expensive part of a food safety recall is nothing I just mentioned. Clearly, the most expensive part of any food safety recall is the damage that event does to your brand and your reputation. And that damage, that hit, can take decades to repair. That's a big part of what's driving Walmart to look at blockchain. If they can minimize the impact of food safety recalls, then just preventing the damage and reputation to their brand will likely pay for the technology investment itself. All right. Well, that brings us to the end of this section. Hopefully, you've got a little bit better idea right now of what makes a blockchain use case, some of the things to look out for, some ways to evaluate and scorecard a use case. And you've seen a few real world implementations where organizations are starting to drive value out of blockchain. So, hopefully, this has been helpful and has really helped to start to shape those lenses that you want to look through when you're looking at the blockchain world. In our next section, we're going to start diving into smart contracts and blockchain development, get a little bit more into the technical nuts and bolts. We'll talk about what makes a blockchain application different from a traditional application. What are the things that are the same? What are the things that are different? We'll talk about what that development lifecycle looks like. What are some concerns around developing and releasing a blockchain app? Again, what are the parts that are the same? What are the parts that are different? We'll talk about what a blockchain project actually looks like. How do they start? What does the team composition look like? What are the things that we need to be worried about? What are the things that are unchanged? And along the way, we'll spend a little time talking about some other Web 3.0 tools. Tools and technologies that are not blockchain, but very frequently come up in blockchain conversations and end up in blockchain solution architectures. So a lot of exciting stuff coming up.